So we're going to take a look at factoring trinomials. Whenever we're factoring a trinomial, we always want to keep in mind that factoring out a GCF is still an important part of the process, and we always want to first look for a GCF that we can factor out, just like we did in our last video. So when we have a trinomial of the form x squared plus bx plus c, and it's factorable, it's going to be factored into two binomials. So I want to do a little example for us to see what this is going to look like here. So we're always going to have x plus or minus some number and then another x plus or minus some number. But we want to know how to get those two numbers. So I'm just going to go ahead and multiply two binomials together. We'll just do x plus 2 and x plus 3. So if we remember from multiplying a binomial times a binomial, we can simply do double distribution. So we're going to just distribute this x through first. So x times x is x squared, then x times 3 is a 3x, and then the second distribution. So we have then 2x and 6. Okay, now this middle term we get, right? So this middle term, when we simplify x squared plus 5x plus 6, we find that middle term by adding these two end numbers together from our original binomials. So we took 2 and 3, and we said, oh, 2 plus 3 is 5. Okay, but then to get 6, we said 2 times 3 is 6. So that's going to be our method for when we factor, is we're going to be given the middle number, right, the coefficient of the linear x term, and the end number, the constant. We're going to have to figure out what two numbers add up to that middle term but multiply out to the end term. So let's take a look at how we can do that. So if we have this first trinomial, x squared plus 9x plus 18, and we want to factor it. So I know I'm going to factor it into two binomials, right? And just like we did before when we FOILed out or double distributed, we always had that x times x giving us that initial x squared. So let's put that in there. We're going to have an x times an x. So then when I distribute, that's how I get this x squared term that we need right at the beginning of my trinomial. So now we have to figure out the two values that we're going to put in here. So what we're going to look at is 9 and 18. And I'm going to do this kind of the roundabout way. A lot of these you can probably do in your head. So I'm going to look at 18. I'm going to look at all the factor pairs of 18. So 1 times 18, 2 times 9, 3 times 6. And now I'm looking at my middle number, and it is a positive 9, so I don't have to worry about any signs on this. So if I'm looking at these, I'm going to say, all right, which one of these factor pairs, when I then add them together, gets me 9? So 1 plus 18 doesn't work. 2 and 9 don't work, but 3 plus 6 is 9. So we're going to have our numbers here be plus 3 and plus 6. Now we can always check that we did this right by just double distributing. So I'm going to distribute through my x. We're going to get x squared plus 6x. Distribute through my 3, 3x plus 18. Combine x squared plus 9x plus 18, and yep, I get my original trinomial back. Okay, so let's factor a few more of these, looking at what happens when we have positive and negative numbers. So if we're looking at this first one, we're going to factor in a very similar way, starting with our two binomials, and the x's are always going to be that first term there. That will change once the leading coefficient isn't 1 anymore, but for now it's just going to stay 1. Okay, so now we want to multiply out to be negative 18. Okay, so now I'm looking at factor pairs that make up a negative 18. And then when we add them together, I want a negative 3. So that means whichever number in my factor pair that has the largest absolute value needs to be negative, so that when we add them together, the resulting number is negative. So we're going to have 1 times negative 18 is negative 18. 2 times negative 9 is negative 18. and 3 times negative 6 is negative 18. Okay? So now I just have to ask which one of these adds up to a negative 3. That would be 3 and negative 6. So we would have a plus 3 and a minus 6 for our two numbers in there. Now, if you didn't get the negative on the correct factor of 18, that's okay, because if you accidentally here had negative 3 times 6, that's still a negative 18, but when we add them together, we get a positive 3. So all you'd have to do is see you got a 3, say, hey, I want that to be a negative 3, and then switch where your negative value was. Okay, let's do a couple more. So here we're going to work with x squared minus 10x plus 21. Starting the same way with our two binomials. But now we have a little bit of a different situation where when I multiply the two numbers I'm looking for together, I get a positive 21. But when I add them, I get a negative value. So I can't work with just positive factors of 21, right? Because a positive plus a positive will never give me a negative. But what I can do is I can say, hey, when I'm multiplying, if I take a negative times a negative, I'll get a positive. So I'm going to work with this where all my factors of 21 are going to be negative. Negative 1 times negative 21. Negative 3 times negative 7. Those are all my factor pairs for 21. Now I want to look at this and say which one of these factor pairs, when I add the two numbers, gives me a negative 9. So the first one doesn't work, but negative 3 plus negative 7 is negative, oops, excuse me, I meant 10, negative 10. So those will be our two numbers to factor out. And again, you can always check. So just go ahead and multiply through to check. So we'll get x squared minus 7x minus 3x minus, plus 21, combining x squared minus 10x plus 21. It works out to the original trinomial, so we're good to go. All right, we're going to take a look at number 5 and number 6 now. So these are a little bit different because we can see that the leading coefficient is not a 1, right? So we have a 2 and we have a 3. So this is an indicator that we should be looking to factor out a greatest common factor for these. Okay, so I'm going to look for the GCF between 2x squared, 14x, and 20. And the only factor they have in common is a 2. So I'm going to go ahead and factor that out. So 2 is going to be on the outside, right? So I'm dividing it out, so I need it multiplying on the outside so that we're keeping the same values, right? But we're just changing what this expression looks like. So once I divide it out, I'm left with x squared plus 7x plus 10. Now I have a trinomial inside the parentheses that I can factor. So don't drop anything off, nothing leaves, because we always want to be able to get back to where we started from. So I still have this 2, but now this trinomial in here, I'm going to factor into two binomials. Okay, so I'm going to look at my factor pairs of 10, 1 times 10, 2 times 5, and I can see 2 times 5 is going to add up to the 7, which is the coefficient of the linear x term, right, the middle term. So we would have x plus 2, x plus 5. And that would be our final answer for this problem, totally factored. Okay. All right, next one. So for this one, it looks like our GCF is going to be 3, and then they also have an x in common. So I want to factor out a 3x. So when I divide through by that, I'm be left with an x squared minus 3x minus 28. Now I want to factor the trinomial. So don't drop off the value outside. Make sure that stays with you. So that didn't disappear. We're just factoring this trinomial. So thinking about your factor pairs of 28, we want to add them together and get a negative number. So that means the larger one should, I should put a negative symbol in front of it. So 1 times negative 28, 2 times negative 14, 4 times 7. excuse me, times -7. Then I want to look at these and say which one of these adds up to a -3. That would be my last factor pair there. So I would have x plus 4 and x minus 7. And then that would be my fully factored trinomial.